want to, if anybody wants to watch this in the future, or if somebody missed it, they can do that. But over to you to get us started.
So let me say hello and kia ora to all our friends from Australia and New Zealand and internationally here. It's great to have you here. Today is one of those sessions that you've been looking forward to. Like in this session, Ken is going to go to the depths of engineering and design of race crossing, lots of insights, and you will certainly come back to us and tell us more. So I want to sort of introduce Ken Beer to you. Some of you know Ken. Many of us in Australia and New Zealand are proud of what Ken has done for road safety. He has opened doors to many of the ideas in engineers in road safety, and we're so, like, how do we say, we're so lucky to have a person like Ken in Australia and New Zealand. Now they're trying to steal him from us in Canada. No, Canada, come on. So Ken, tell me, what is your vision in road safety?
Well, I'm fully committed to the safe system vision, which is a road network free of death and serious injury. I know it's a lot. Well, it's a while off, but I think if you just look at the principles that could get us significantly towards that and applying those, that's the important thing.
Oh, that's fantastic. So to achieve that vision, I know that you do many things. You have your fantastic safe system solutions. You have your own sort of, role there. Tell me about what you do, where you are now. Tell me some about you.
Yeah, certainly I've always enjoyed the specifics of working at on a crossing, designing a crossing, road safety auditing a crossing and these sorts of things. But increasingly now just trying to instill the fundamental principles of safe crossing design or, roundabout design or any stretch of road design into a lot of people so they can then share that information with others and we get that push of it in a really wide manner. So there's, tens of thousands of crossings being worked on with really good road safety principles. So that's my focus these days.
So Ken, I've got some information about you, but I want to focus on one of them. Like you are said to have done hundreds of safe system assessment frameworks. My question is about this. In this course today, so you have so much experience, you have done so much of this safe system assessment framework and engineering design. How are you gonna weave that in the training today? What's the benefit for our people here today? Tell us that.
Well, I think you set a wonderful start to the course in strategically showing the importance of raised crossings, how beneficial they are to the community from an economic standpoint, and also from the health, well-being, sustainability, and all of that. Bridget came in beautifully to have all that accessibility, ensuring that our network can be used by all road users. Prue started to delve into, well, where are we going to locate these? Where do we get the best bang for the buck in expenditure? And I'm in here now to start to talk to some of those how are we going to do that? We often have strategic planners and the like getting frustrated at the engineers because they're saying, well, we can't do that for this reason. I'm going to explain some of those reasons and maybe ways we can think about altering that and still getting the principles. And then often we'll have the engineers who are wanting to push for things, but there's other reasons. So I'll delve into a lot of those details and we'll see how much we can get through.
Fantastic. Ken, the floor is yours. The privilege is mine for facilitating your session today. Go ahead, man.
Awesome. Okay, and Hafez is going to be in the background there, collecting the questions and comments. I'll be asking you, everybody, some questions as we go. And also at the end, I'll just show you in the learning management system how to complete the course. Now, my contact details are there in your notes and on screen. There will probably be things that will pop up that you want a bit more information on, you want to have a further chat about. Please feel free to shoot me an email. I'm happy to have a chat. There's a QR code there to my LinkedIn, and I try to share some good road safety engineering style knowledge, either from myself or from Safe System Solutions through that platform. So connect with me. Yeah, so here we are, beautiful Warrnambool City, for those who know it, in Victoria, with some lovely raised crossings around a roundabout. And what am I going to talk about today? Well, I'm going to go into the ramp grades, signs and lines, and I do. I feel quite excited that we've got some absolute signs and lines gurus in the audience here, so they will correct me if I make any mistakes. Roundabouts, as a particular interest in roundabouts and crossing points around roundabouts. Sight lines, spend a lot of time on sight distance. I think it's a very poorly understood element of the design of raised crossings. Lighting, drainage, I'll cover off some of the fundamentals. But really importantly here, I want to say that there are jurisdictional nuances, all right? And we're doing this course for across Australia and New Zealand. And so there might be specific jurisdictional nuances that I'm not going to cover. My key is to instill the principles and point you at the different documents where you'll get some of that. But I will delve into different jurisdictional specifics as needed. Okay, so overarching, and this is a bit of a reminder of what my three colleagues have beautifully outlined there. In general, our design objectives are to locate crossings on pedestrian and cyclist desire lines, and that they serve the road users through efficient and effective crossing. We want them to be able to be traversed by all road users. We want them to have high alignment with safe system principles, and we want to consider it at that network level. So there's a sort of your design objectives. But if we get into design principles, this is where I start to, this is a point I'm constantly challenging industry on often. And you'll see there, I start with severity. And that's been a massive change in my career. You know, I've been doing road safety audits for 20 years or so. And I used to look at the road network solely from a likelihood perspective, or not solely, but almost solely from a likelihood perspective. I'd be saying, oh, we've got the right sight lines. Is there a see-through effect here? You know, is the lighting right? And all of these things. Right, but transitioning now, I'll be looking at the whole road network on potential energy. So I'm saying, okay, what's the speed here? What's the vulnerability of the user? What are the angles that these crashes could happen at? That's the first thing I'm thinking about, right? And then it's still very, very important to think about all those likelihood factors, but they, to me, sort of sit then in there a little bit under. So are we thinking about, so we're thinking about sight distance, good signage and line marking, conspicuous, clear, concise, comprehensible, credible, system compliant, all those C's. Add any more C's in if I've missed any. Good drainage, appropriate lighting, and then speeds again, because that helps in the ability to reduce the chance of a crash as well as the severity of the crash. So I'll be taking you through those design principles, and we will delve right into some of the detail here. And I want to start with sight distances. And I will start with a few probably thumbs up, thumbs down style things. Let's start with this one. Okay, it's an at-grade crossing. It's not a raised crossing, but give us your thumbs up, thumbs down. Now you can do that with the icon or the scary face. If scary face is your thumbs down, or you can type it into the chat, whatever works for you. Okay, this is interesting.
Yeah, it looks like maybe like 60-40, 60 negative or more negative as we go by.
So we've got two lanes going in that direction. So it's two carriageway. Oh, okay. We've got a lot of scared faces at the end. Yeah. People. There's some sort of thing going on. Maybe when I said there's two lanes in that direction. Okay. I suppose the good aspect, some people are saying there's some good, I mean, it's got lighting. The lighting's pretty good there. It is a pedestrian crossing as such. But as a few people are pointing out there, the thing that we always get concerned about with these multi-lane in the same direction, and I use this diagram to try to explain it, is we've got, I'm just going to get my pen going here. If we're thinking about this car here and it's approaching, and this car slams on the brakes because a pedestrian is crossing from the middle, we've got a sightline impediment there. Dynamic visual obstruction is what we'd call it. So that vehicle blocks that sightline. And if they're slamming on the brake and the pedestrian is walking past, we don't have that open sight lines that we wanted. Now, the Australian Standard does sort of talk about this and says we don't have pedestrian crossings on multi-lane roads like this, but it is done in jurisdictions, as you saw there. Queensland seems to have quite a few of them. Certainly, there are ones that are in other states as well. So it's an interesting one. But let's have a look at this one. Again, we've got 2 lanes in the one direction, and we've got a pedestrian crossing there. Yeah, so it's another divided carriageway there. Let's see, thumbs up, thumbs down. Ooh. Okay.
We're almost unanimous on this one.
Yeah. Flashing lights not working is a good pickup as well. I'm trying to think. It was me. I'd ridden there with my colleague to take some photos who's over there not riding over the thing, but I can't remember whether the lights were flashing or not. But anyway, there's a few critical elements here that help us explain what sort of good principles of race crossing design are. And I'm thumbs up on this. I mean, because let's have a look there at one of the features that really helps me go thumbs up on this, and it is that use of a separation in between. And this was a question in last module about, how would you do a pedestrian crossing on a 2-lane roundabout or the like? And this is one possible way. I did say in the comments I was writing back, it's a bit expensive. You've got to widen, you've got to have the space to do it and the like. But the principles are pretty good, because you can see there that the sight lines are open, even when there's a truck that's slamming on its brakes on the approach to the crossing. I can still see clearly a vehicle approaching of a pedestrian there. If it wasn't there and you were running 2 lanes right next to each other, the truck really starts to block out the sight lines for that pedestrian emerging. Okay, so that sort of separator in the middle there, if you can add that in, you really open up those sight lines and essentially able to achieve your sight lines. Yes, there is still a dynamic visual obstruction, but the distance you've got between there, sort of that sight line there and the crossing point is meeting most requirements. The other beautiful thing about this one is the raised nature of it. We've slowed things down. There is more time to see, to react. And so your sight triangles are lessened. So it's a really neat way to do it. So that one's down in Port Melbourne area, just near the pier there. Station Pier, is it? Okay, let's keep moving on. Let's get into a bit of, I suppose, technical detail around sight distances to crossings. To do this, we want to take a few sort of standard variables that we use in this. And a few things that I'll be using a little bit later on are 1.2 meters a second as a walking speed. It's taken as a bit of an average walking speed. Now, you would adjust that if it's hypothetically here. I mean, if it was a park and there was a path that led directly up to this crossing, you would have to think, okay, there will be likely joggers and people moving along faster. We might need to up that a bit. But this is kind of what we think about in a normal environment where there's a footpath and there's a crossing and these sorts of things. 1.6 meter setback is a really important number that's used in raised crossings or any crossing sight distance thinking. It's an appropriate point for pedestrian setback, and I'll come back to that. And I've got a 1.07 for height that we're thinking about children or people in wheelchairs. It's very precise, whoever came up with 1.07, but hey, it's there. It's used in a lot of the documentation. Now, here is what I would say a big common mistake, especially done by local governments. Okay, the local governments, designers and the like will often just simply revert back to this little bit in the road rules that says a driver must not stop on the pedestrian crossing intersection on the road within 20 meters before the crossing, 10 meters after the crossing. And they say, well, that 20 meters, as you can see down here, that 20 meters is there to open sight lines. Okay, that was the purpose of that road rule. Okay, so that's got to be fine. In New Zealand, for those logging in over the ditch, it's 6 meters. Okay. The reason I'm always nervous with anybody just saying, well, that's where we'll put our car parking or that's where we'll ensure the sightlines is it's really a generic sort of open, okay, we'll provide some sightlines. And there are many, many situations out there where 20 meters is excessive and it's stopping us putting crossings in. Like it really excessive, okay? And there's plenty of situations, or not as many, where 20 meters is not enough, okay? And there's dangers with having that, having only 20 meters. So let me tell you how you should be doing it from first principles in terms of sight distance on the approach to different crossing types. Okay, so you use your stopping sight distance calculations or safe intersection sight distance calculations, same thing, it's just at a different height, but SSD. And you've got a vehicle approaching and you go 1.6 meter setback, and then you want to have that sight triangle clear. What distance back are we talking for that vehicle? Well, that's going to depend then, as per the formula there, what is the free flow speed? What's the 85th percentile speed? And let's say it's 50, maybe they're coming in there at. Okay, we take then our reaction time, and I'll always use for reaction time, well, I'll look at the environment that we're in, but the bulk of the time it's going to be in the 1.5. Reaction time will be quick because pedestrian crossings are put in places where there's stuff going on. They're not out in the middle of nowhere where people have been driving for 4 hours. So you know reaction time is going to be good. So I drop almost always it's 1.5. In terms of then your coefficient of deceleration, which is that other key sort of choice you're making in there, 3.6 is good because it's factoring in that wet road and 90th percentile. So if you go, less than that, there are going to be situations where we might have, not giving us the best safety potentially there. So you've got those. If you've got a longitudinal grade, you'll factor that in, and you've got operating speed. So you just plug that through your calculation, and you'll see there that we then get, say, 48 meters at that 50. It's coming in. I mean that's a fair distance, and yep, you'll work out where you can put the parking then and the like. So that's how we do that. But this is an at-grade crossing, isn't it? We don't have any raised elements to this. So how does it work then if we actually raise the crossing? Well, a lot of people just stick to this, this formula because there's not really a lot of other guidance other way. But that doesn't make sense. If you just stand back and look at that and you go, well, that doesn't really make sense, does it? Because that car will slow down. It's going to slow down because it has to navigate over what essentially is a speed hump. So what to do with that one becomes really interesting. So you can then say, well, okay, what about we take that distance and we base that free flow speed off the ramp grade speed. So the advisory speed we're putting on that ramp grade. And then we're significantly going to shorten the sight distance calculation or the distance there compared to our free flow speed back here. And so then you're able to really shorten up your sight triangles and hopefully get more crossings in where you may have said not to. So then you can see it's down to 17 or so there potentially. Now, the reality of this is I've tried to explain this in a diagram here, where we've got what happens is that a vehicle is coming in at a certain speed, and let's say they're traveling at 50. Okay. ASD, approach sight distance, is ensuring that, yes, that vehicle, when it hits this point, can see that they are going to potentially have to stop at that location, or they're going to have to navigate over this raised area. So we want to ensure that we've got that approach sight distance. So they're going to process that information, and then they're going to start to slow down because they're going to have to navigate something that they don't know whether a pedestrian's there or not, potentially, but they're slowing down anyway. And so we then slow down, and then there's this point, and there's this point where they're going to make that decision as to, am I going to, travel along at this appropriate speed now to navigate over this, or am I going to stop? And that's the critical decision making. Now, what happens at this location is that the driver already has their foot resting on the brake because they are slowing down. So we've even improved that reaction time for that decision making. So we're able to account for that in our sight distance. So you can see there, that's the kind of way we think about sight distances on the approach to raised crossings, allowing for that slowing down, which is going to be happening anyway, and a lessened sight line. So you can really start to reduce your sight triangles by raising the crossing. It's all based on a 2.5 meters a second deceleration, which is out of Australian Guide to Road Design Part 4A. I don't need to go into that now. Okay, and I'll take any questions in a minute there, Hafez, if they're coming in. I just want to cover this off because some people then ask, well, they say, hang on, okay, why are we not then? There is a requirement to give way at this location, which, hey, in theory, should be no different to approaching a road that you don't have priority on. And so why aren't we just looking for, say, gap sight distance, like enough sight distance that this vehicle has stopped here, they're looking, have we got enough gap, and then I'll make my move. The answer to that one is that people don't drive a pedestrian crossing the way they do approaching a non-priority intersection. Okay, they approach it like it's a speed hump, and then they will make a stopping according if the pedestrian is there that they see. I think that has sort of covered that. I'll pause there for questions. If there's anything I need to deal with.
100%. So SUVs, like, as you know, like have been like on the rise with several like implications for pedestrians, and so what are your thoughts and how that sort of phenomenon like impacts your design?
Yeah, so it is a really good question, because like these larger vehicles can navigate over raised crossings at higher speeds, and they often will. Lowered vehicles really have to slow down even more, so you get some improvement off that end. But we face this with all design decisions and challenges where we're trying to cater for the bulk of vehicles, and you get yourself all tied up in knots if you're looking for things that cater for absolutely every vehicle we have out there and all those challenges. This is a sight distance calculations, so things like deceleration, heights, eye height of vehicles, speeds we expect out of different ramp grades and the like, that will vary. And what we've got in our different standards and guidelines sort of accounts for the bulk of them. Good question.
So two more specific questions, Ken. One question is about why 1.6 meter setback, tactiles will be 0.6 meter.
Yeah.
Why?
So, my understanding, I was not involved in the choice of 1.6 and have just but my understanding it was associated with that speed of walking and providing that appropriate time between that point back and the pedestrian reaching, starting in the crossing. So that's that's it. The tactiles will be at a point, I think, where vision impaired will have are sort of at the crossing, they know to stop then if, or that they're actually entering the crossing point.
Beautiful. And our last question, more specific. So what if the operational speed is different from 25 kilometers per hour? What if it's faster?
If it's faster, you should be accounting for that in your sight distances then. So that's our role, is to understand and make appropriate judgments on operating speeds and work things out according to that. So you certainly, it's like speed limit. We don't do normal sight distance calculations on speed limit. We do it on operating speed, and we make a judgment on that. Sometimes we have data that helps us. Sometimes we don't, and we might say, oh, okay, well, it might be a bit more in these rural environments. So we'll usually add 10 kilometers an hour in the rural environments to a speed limit if you don't have data to back that up. But in urban environments, you tend to, without any other information, take the speed limit itself as operating speed.
Can we put, my personal question, can we put humps in front of raised crossings to bring down the operational speed to 25k and then design for it, if,
Well, that's a great question, and it's actually leading into exactly the question I was going to ask the group now. So I'm going to ask, so Hafez has given a little bit of an idea, like, what if we're not meeting this, sight triangle? What things do you think we could do? And pop these into the chat. What are your ideas? Hafez has given a thought. Well, could we possibly do that? Any other ideas? What could we do if we're not quite meeting this, this sight triangle that we're trying to achieve? Let's see what people come up with.
So we're getting a number of physical, vertical, and horizontal changes on the road. We have safety technology like cameras for speed management. We also have asphalt art and putting paint on the asphalt. So we at least get 3 different departments and also signages. So we have 4 different type of solutions people suggest.
So one that came in very early, and I really love the curb out step, or curb build out if you're in New Zealand. Like, you immediately open up better sight lines, don't you? Because that 1.6 meters is all of a sudden pushed in as much as you possibly can there. So you're really able to do some wonderful things with those curb build outs. But then I really do like these thoughts people are having about, well, hang on a second, I understand the principles you're talking about there. So if we could slow that vehicle, as Hafez said, we can slow them down earlier on, we can really get some good, we can tighten things up. Now, I will show you an example, a picture of that later. I thought it was the next slide, but it's not. I just want to cover off another principle And then I'll show you some pictures of how you can slow vehicles on the approach. And really great to see some of the ideas there, humps, cushions, narrowing the road even to bring operating speeds down, all good stuff. But here's, I think, an amazingly important principle that we can utilize design specifics on. Okay, what we've been talking about there is sight distance for a vehicle to see a pedestrian. Okay, the pedestrian stepped out. The vehicle has to give way. That's what a raised crossing is. In the situations where it's not pedestrian priority, okay, the vehicle has priority. What we use is crossing sight distance. Now, crossing sight distance is all about a pedestrian having time to see a vehicle, right, pick a gap and scurry across the road, and we take then that speed that we had for walking. So if we do that, we've got that 1.2 meters a second as the walking speed there, and we've got our other detail in there. It might be say 65 meters or something like that with a 40. So what we're saying there is that it's actually this distance that a pedestrian needs to be able to pick their gap and move across the road. Okay, so in these situations, we often cannot meet that where there's a crossing point, a pedestrian refuge, or these sort of things. If we put a pedestrian priority raised crossing in these locations, we can absolutely meet a lot of the requirements. Okay? We may not be able to meet the sight triangle calculation, but we can usually definitely meet approach sight distance, thus giving the driver the awareness that the crossing is there. So in these sort of situations, we're able to have that driver approaching, realizing that there's a crossing there, and we'll show you some other measures we could do to address the car. So what we've done there is taken a situation where our pedestrian absolutely does not have enough time to look, to make a judgment call, to pick a gap, to scurry across the road in a gap, to a point where a vehicle approaching can absolutely identify that there's a crossing, knows that, has appropriate stopping approach sight distance. Sorry, so we're in a much safer position by having pedestrian priority on a raised crossing than we are having the pedestrians trying to make their own, run across the road. Plus all of those other equity and things that Bridget talked about. Think about old people, yeah. So it's a really big win, and we can really start to sort of justify that. And you see it play out like in these points, especially around urban roundabouts, where I've seen these be denied based on that, right? Driver approaching, and there's often buildings and other things in the way. And we saw Crew had a picture of one where there was a big, planting and gutting, and they say, well, we can't do a pedestrian priority because we don't have the appropriate sight lines, and it's dangerous. And the reality is that you've got that sight line, and it's pretty well aware. Plus, the other thing is that you usually would do these in all approaches, which brings down that speed people are turning anyway. So I think that, not meeting sight lines to a pedestrian crossing in some of these locations isn't a satisfactory reason, or you just got to calculate it and think about it slightly different to ensure we can provide this safe and effective access for pedestrians. Before I jump into questions again, let's do a thumbs up, thumbs down on this one, or thumbs up, scary face, as you decide. Again, we've got a Acro crossing there. I think some people were talking earlier about the importance of having crossings at bus stops, because people get off the bus and there's a bus stop on the other side. You can see it, so you've got to provide that access. Oh,
The
but yes.
summary is nicely done by Rob. Bloody terrible.
Okay. And then Rob is an excellent road safety auditor up there in New South Wales, and so no doubt seen some of this sort of stuff. But yeah, that's right. I mean, we've got to think about that dynamic visual obstruction, the vehicles. Maybe it's not there the bulk of the time, but actually just at that point where a whole lot of people are going to get off and start crossing, we are going to have a big sightline impediment, as we talked about. Let's have a look at this one. What do we think here? Okay, now ignore the not in use signs on the flashing lights. They just haven't been switched on yet. Doing a post-opening road safety audit with a colleague on this one. Give us a thumbs up or a thumbs down on this one. Yeah, people like it, don't they? But I like it as well. I like it on many levels. It's got the it's got nice sight lines there. It's got correct signage and line marking, and it's raised, and really looking good. And doing the nighttime inspection, I'm a little disappointed to see people parking in the no stopping area though, just on the approach. So sometimes you might have to look at features to just make that so you can't actually get into that little wedge that we want to keep protected. I mean, it makes it sometimes a little bit hard to do parallel parking in there, so you've got to design it a little bit. But yeah. Now, I think there might be sorry, I just saw something flashed in the corner of my eye there about limit lines. Now, that's an important thing to understand. That will be a New Zealander asking about limit lines. Yeah, Australia doesn't use a limit line. New Zealand will. That setup in this one is correct for an Australian line marking. I'll show some New Zealand ones later where you'd put a hold line. But I'm talking about that principle of trying to absolutely keep those sight lines clear. Now, this is definitely all marked correctly in terms of no stopping on the approach as it should, but it didn't quite make it there. Now, you don't really have enough information on this one. Thumbs up, thumbs down. I think, yeah, I can probably skip through it. I mean, it's a fairly thumbs up one for me. I like what they've done. It's nicely raised. They've got curb out stands, build outs, good tactiles. Everything's pretty good. Yeah, you might want to have a think about something here just to stop it when somebody can't find a park and they park right in up here. But in general, we're in really good territory here. I am interested though in always ensuring or trying to ensure that we think about the sight lines on up to a height there, and that height that we talk about, there's debate out there as to exactly what that height should be that you don't want obstructions. I showed you back that wheelchair at the 1.07 height. Now, people will say, well, that's the height, it says it. And I say, yeah, I don't think that that's adequate. It's too high. If you had bushes up to that high, if somebody in a wheelchair is approaching, all you're going to see is the top of their head. And a kid, again, yeah. So there's a 0.5, so it's 0.5 to 1.5 window that you should certainly be keeping clear as a good rule of thumb. So just low ground cover. Low ground cover is fine. Be aware your landscapers are going to just their eyes light up when they see that little bit of land. They want to jump in there and put exciting features, big trees, but they also sculptures and rubbish bins and all sorts of stuff wants to go in there. It's probably a good one to try and keep clear. Maybe you can put some of that stuff on this side because you've got better sight. Anyway, okay, another one just while I'm sort of talking a little bit about those areas. You can see some beautiful vegetation there, which is nice low stuff. This is a neat way when you're doing, you've got angle parking near a crossing, which is that you don't want people backing out over the crossing. It's not a major safety issue, right? But it's annoying that they go into the crossing and people have to go around, and it just doesn't work well. So I love this fact they put their disabled parking there. They put that gap there, which gives a buffer for that, and you're not going to get as much crossing there. So a nice little choice on what to put at that location. Okay, but I've been talking about pedestrian. Oh, fair. So I said questions. Yeah, I promised I'd answer questions. Yeah.
Yes. So one specific questions. The V in your formula, is it the approaching speed or speed at the pedestrian crossing?
As approach speed.
Cool.
Yeah.
And one of the series of comments here is about cyclists going along the road, and when you narrow the road, there is or maybe implications for them and their safety. What are your thoughts on narrowing and cycling mobility and safety?
Yeah, so there's that's especially the case when we do curb out stands or curb build outs and other narrowing features. So I love a cyclist bypass lane, and I'll show you some examples of that style stuff shortly. So if you can have it so that vehicles are squeezed up, but cyclists have a unimpeded flow outside that, beautiful. That works well. The other one, and then I'm going to sort of, I'll do this fairly quickly, I reckon. I do like this on the approach to a roundabout often, is that but it applies equally at other points. If you've got a point where a cyclist is coming up here and they're going to have to sort of merge in, I love putting a speed cushion about there. So maybe that's some sort of island on the approach, about there, right? And you've got the cyclist then comes up and the vehicle has to slow down right at this point, and the cyclist comes in. So the cyclist, so because the reason for that, there's only a certain point in time and space where this is a problem. And it's where the vehicle is approaching the cyclist at speed from behind, right? And they push through. If they're going sort of side by side, the vehicle tends to have that speed to accelerate. But what this does is it forces that time and space where it's a problem, the vehicle has to slow down and the cyclist goes in front. So you can use similar things if you are worried about those squeeze points. Okay, so we talked about, so Prue talked to you about her banana crossings, as she calls them, but the yellow marking is the sort of the done thing now for where it's a pedestrian and cyclist priority across a road. And it's marked with one of these. Now, the reason for that, as people have pointed out before, and it was interesting, posted something online, and there's lots of debate about why can't we just have bike riders be able to ride over pedestrian crossings? Some other states do it. Now, I fundamentally agree, and it would remove a whole lot of confusion. But if you're going to do that as a state or a territory, right, what you need to do is go back and say, hang on a second, what are the sightline issues at existing pedestrian crossings, and have they accounted for whatever speed that the cyclists are becoming? Now, the bulk of cases are going to be fine or will be assessed as very low risk, and that's fine. But there may be circumstances where sight lines are not adequate for an approaching bike rider of a certain speed. So that's a caution on that, on going down that track. I think it's a good thing overall, but most jurisdictions are going down this track of saying, well, let's create this environment as essentially an intersection. Think of it as a road-to-road intersection where the shared path is a road and the road is a road, and the shared path is the priority road. Okay, so that's why it's got a give way sign. It happens to supplement that with the cyclists and pedestrians with a little supplementary, but essentially that's the kind of look and feel of it. So when you're thinking of bikes, though, it becomes a little more challenging. Okay, we're going to go 1.4 as an eye height, fair enough. on earth speed would we use here? And so TMR's done some good stuff on this and has some nice information in it, 4.1 to 6.9 meters a second. But what I will take you through is some stuff around sightline. The Victorian government has released a really good document around considerations for these crossings, and they've done the sight lines as good as anybody I've ever seen. So I'm going to use that to explain the principles. In Victoria, you're going to be using that. In other jurisdictions, the principles are very, very sound. Queensland has released some other principles which scale some things back, which are interesting. I'll point you to those as well. Okay, and I will show you that. But I just wanted to point out, and here's actually a neat cyclist bypass. For example, this one happens to be on the approach to a roundabout, and it's got a nice protected roundabout feel to it. But you know, that sort of theory as well links in quite nicely. If you're going to do curb out stands on the approach to a crossing, you could have bikes go around the back. Creates bike to pedestrian things you've got to work through, but that's not bad. But if you've got these situations where you have separated bike facility, green, pedestrian crossing, raised pedestrian crossing, one back crossing there, you're going to be thinking about your sight lines on the bikes because they're the faster of the vehicles. Okay. I think there's lots of questions coming in.
Oh, I think like people are answering each other's questions as well, which is great.
That's good. I'll log off. I'll log off. Keep going, people.
And also, your current picture addresses some of the questions. There is a comments about Sharrows. I think you're going to cover Sharrows later in your training today.
No, not really. Sharrows. Okay. I mean, that's the shared bike and vehicle sort of symbol on the road, just to indicate the point where that vehicle might be approaching and the cyclist might be coming in. So you put your Sharrow just after that speed cushion I talked about, so they know that, okay, that's that whole point emerging. Yep.
And one comment that, is like, it's implied here, like you do the best design, but still people find a way to go around your design. You put the cushion in and people go around it. Or you might have a design and people like reverse back to your foot, like, race crossing. So what can we do with human nature?
Well, you keep working on your design to sort of try and account as much as you can for behavior. I will talk actually to that because it's a really good point that vehicles will try to go around your cushions. Absolutely. That is what they'll do. But we can design that out. And I'll show you some examples of that shortly. Good, thank you. And excellent. This F's answering nice questions in there about the spots to find some of the things in the Australian standard. Let's ride. Okay, we're riding up to one of these crossing points there and riding across. But let's do that again because I want you to see. There that I want you to watch the white car that's approaching from the right, okay? So we see a white car in there and approaches from the right and everybody sees each other and slows down. Nice sight triangles. I'll play it once more. Watch see there, riding along, and as you're the bike rider, you've seen the vehicle coming in, you're slowing down, stop. We're good, keep going, okay? I point you at this technical note. I think it's really good. In some little aspects, it's a little bit conservative, but that's okay. I think somebody's gone to the effort now of actually documenting how to think about these race priority crossings really well. TMR has a really good document on this as well. You should have a look at that. But I'm going to talk to you about how you think about sightline requirements at these types of crossings. Okay. And the fundamental principle is that we want to think of it more as sight lines kind of at a roundabout, in the sense that you want mutual sightline ability there for both the cyclist and the driver to be able to see and make a judgment about what's going to happen. Now, in order to do this, we set ourselves what we call a travel time. Okay. Now, the travel time is that observation and reaction for both users. So it's a time we're talking about here. So that's for a vehicle, the time to see, to react, and for a bike rider as well. So then there are some scenarios here. If you're in these very, high speed environments, we're talking about 70, 80 kilometer roads. There we're thinking we want high travel time allocation. Low environments or really constrained scenarios where you can't, meet these, you might be down to 2 seconds. So like, just to ensure everybody's on the same page here, I'm just going to say, so if we've got these scenarios, we don't have good sight lines, we've got very constrained trees or buildings or things bunched up in there, you're going to have this issue where, maybe the driver goes through, we've got a faster moving vehicle and we've got a crash. We want to ensure some sort of sight triangle there opened up like this. So we have the two options, where we have either what's going to happen is that the vehicle nicely slows down, stops, and the bike rider goes through as per the road rule requirements and the way it should operate. But we also want to cover this scenario where that car does not stop or enters through the crossing, but the bike rider has enough time to react and evade. So I'm going to show you sort of how to calculate this and work this out, because now we're adding that variable of speed of the cyclist into the equation. Back before we had that 1.6 setback, which took it all into account. But in these situations, maybe we've got a shared path that's running along the side of a major road. And that's really common because you've got a bit of land space there. You run your shared path along that. It's an arterial road or something, so you don't want bikes mixing in there. But how do we then work out what we've got to do? Well, we want that vehicle there to be able to see a cyclist approaching the crossing. We want them to be able to see the conflict point, and we want them to see a bike rider approaching from the other direction. Okay, at some point back B and at some distance back A. We want the same at these locations, and I'm just going to draw you a slight envelope in this. So there we have it. That's the area we're trying to keep free of, major sightline impediments. So you might still have a power pole or something in there, but it's major sightline impediments. So to do this and to work out that A and that B, we're going to use that information we had before. So I'll give you another design scenario and then I'll work through the actual figures on it. So the other one we have, it's not a road running parallel to the shared path facility, but it's going to run perpendicular. So we're crossing a shared path, maybe mid-block. Okay, so that's another one there. And another scenario you often have is that it's running along, but then it needs to change over. So we've got that sight line that we're trying to keep clear there. So there's sort of 3 scenarios that are thrown out there for you. Okay, let's actually calculate through A. And A being, you can see A there. That's what we're talking about. What distance back are we going to have it for the cyclist? And then we'll work out C or B or the like. C for these ones, and it's B for that distance to curb return. So remember I said we've got to select this travel time scenario, and it's based on these, these scenarios. So you pick one of those. Select a travel time based on these scenarios. And then we're trying to work out A there. What is that? What is that A? How do we get that distance back where we're going to plonk the cyclist in our sightline calculation? Well, you use this table 2 out of the RDN is a really good gauge of doing it. You can do all of this back from first principles if you want, but it's been done for you, which is very handy. So you pick whatever your travel time is, and then you say, okay, what speed is that bike rider going to be approaching at? What do you think they're going to be coming in at? Now, you can see there we've got 30, 25, 20, or 15 in this scenario. Okay, and this is your judgment call. Again, okay, if it is a bike facility only, or it's got, big bulk of bikes and they're all going fast, you might be up in that 30 and be allocating that. Certainly if it's just a cycleway in its absolute own right, then yeah, you're up at 30 because you're going to be taking that into account. And that's moving for a cyclist. Yeah. Oh, good. Hafez is answering stuff on e-bikes, their speeds, but up around that 30, they're moving along pretty quick, right? If you've got low speed environments, or you've got a really interesting geometry on the approach to the point that slows the riders down on the bike, you can be down at the sort of level of 15 or so. And you simply then are able to say, well, I've selected a travel time of 3 seconds based on some scenario, and I'm going to go with 20 on the approach speed, which is usually, what's often done, and we know it's a 17 meter. 4A, that's the setback for the bike. And you can find your corresponding A. And then you're able to do the same then for your B or C, which is the vehicle setback. And you've got their approaching speed of main road here. So that would be the free flow speed of this vehicle, B. And then you go, okay, we were talking to 3, and maybe it's a 60 km/h. So we're going 38 meter setback there from curb return. So that's 38. And I forget what I even had for A, but 17 or something. And then you've got the point where you're going to need to be looking to keep those things clear. And then C, you've got this one. So yeah, approaching at whatever speed, 50, and 3 down to 21 there, for example. So I hope that's sort of giving you some of the ideas on the principles of it. You can sort of see there, 20 is a common one on bike speed. And then, yeah, you've got whatever speed you're approaching there, which you may actually reduce down based on having some of those raised facilities as well. So TMR's got a number of different guidance documents. I think they've done some really good work on it. They've got interesting stuff around shared paths meeting each other and shared paths meeting sort of roads and the like. Essentially talking about a setback of 4 meters and 2.5 in constrained situations, which is a bit more, it's pushing a bit further than some of that Victorian guidance if you run with that. Questions, and I'm going to be asking the group this one. Again, what if we can't meet some of those visibility requirements for these scenarios where we've got shared paths crossing roads? So Hafez, questions for me while people ponder that as well?
A couple of quick ones. So table 1 and 2 that you showed, where people can find the data on them? Where are they? Are they in the VicRoads design notes?
Yep. So they're in the road design note, and I've put that into the learning management system folder of resources, and I'll show you that at the end. You could just Google it if you wanted, but that's certainly there.
And there's a question from Alison here. Just wouldn't it be better to design for the fastest speed when we're designing? And maybe I'll complement that question by asking, can we also manage the speed of bicycles if we cannot cater for them? Yeah.
So to answer Alison's question, I mean, in an ideal world, yes, you would be doing that. And if you had an absolute, greenfield site and the freedom to design things with lots of funding, and they're not asking you to minimize land take and all of these, absolutely, that's great. The bulk of scenarios are in brownfield sites. It's really hard and ugly to try to do this, and there's pressures on cost and all of these other sorts of things. So you're making that sort of that call to ensure that you can get it in. If we said cater for the faster cyclists and always do it, what we would probably end ourselves up in is a situation where we wouldn't be giving cyclists and pedestrians priority, because it just you wouldn't actually be able to do it. There'd be a building in the way, there'd be these sort of things. So yeah, but that being said, we're getting some ideas in there as to how we might even be able to sort of get the best of both worlds here, which is, creating environments where the maximum speed is actually a bit lower. And just a few ideas in there. So I'm still talking about managing the speed of the vehicles on the approach. Okay, so then we can think about the cyclists. Okay, maybe we can manage the speed of cyclists on the approach. And then maybe working in and starting to go into these situations where you're, going into minimums of design choices and the like. Right at the bottom there, you may need to get to the point whether that's actually the most suitable treatment for that location, and looking at potentially points where you get raised signalized crossings, but it's clear that the riders will have to stop at points and those. But there's one. It's a different scenario, so it's not a raised crossing, but you can see they're slowing vehicles on the approach to the shared path crossing. That was actually done with some drainage challenges rather than specifically what we're talking about, but I latched onto it. You can see speed humps back here, slowing vehicles at these approaches. So that's certainly an option. Another one, kind of lowest form of control and the like, but you could be thinking about actually creating stop situations. I'm always cautious that don't be that traffic engineer who thinks just because I put a stop sign there, everything's fine, everybody will stop. But it's part of the possibilities if you've done some speed calming and you're stopping vehicles. I'll pause there, Fez, see if there's anything else I need to talk to. I mean, I talked the whole 2 hours on sightlines, and it looks like I've already done an hour on.
Yeah, I think we're safe, and considering that we have so many other material, and maybe I suggest we continue and we have other poses, yeah?
Well, maybe we give people 3 minutes to stretch, fill up a coffee, come back, and I'm just going to power through a few more design principles.
Beautiful. So people, it's 3+1 in Melbourne. I don't know what time, but 3 minutes. We'll come back and we continue with Ken.
Awesome. Thanks. See you soon.
Thank you. I'm here and having my apple.
Okay. All right. Well, I'm going to get back into it.
Let's go.
Okay. So let's talk about roundabouts, positioning of raised crossings around roundabouts. And I talked a little bit about that before, associated with sight lines and the like. But really, there's two options you have in positioning. One is to put it right up on hold line, as you see there, option one. And option two is associated with setback about that 5 to 8 meters. It's essentially a car length, I suppose, is what you're trying to sort of set it back, about a car length. Now, you can see there in my little diagrams, if you have it right up on hold line, you've got the issue where pedestrians crossing will be they'll be blocking vehicles, which means that other vehicles can't circulate. The circulating carriageway will be blocked by vehicles. Now, you may not have a problem with that, and there's lots of environments out there where we said, well, pedestrians are priority, and who cares if it's no good for cars, because they shouldn't be in this area, and if they are, they're going slow and they're not going to have a good time. should walk or ride a bike. So that's fine. You can do that. This one has that circulating area, so at least one vehicle can be, propped, waiting as pedestrians cross, and other vehicles can circulate around. But the other advantage, I suppose, of that setback is associated with the vehicles entering the roundabouts, not exiting. So you can see there that when you do that, that vehicle has the ability to navigate over the pedestrian crossing and pause there. But we often will find then that when you put it right up on a hold line, vehicles are sitting right across your crossing as they wait. So it's not ideal. Again, I don't say that this is the biggest road safety concern we've got out there. It's an annoyance, and people have to sort of walk around and go like. But it's not the neatest scenario. So I sort of say preferred if you can do it, but don't discount putting raised crossings in just because you can't get that setback. This is better than not having the raised crossings at all, and it works okay. I'll happily, if others have experience, you can share that. But there's an example. You can see there that the bit of setback, it's nice there. And yeah, it functions really well. The other one, there's a couple of other things on this. I mean, this is closer to the pedestrian desire line as well. So this one, walking them out of there away. So there's a bit more thinking to be done with that. And also, yeah, the footprint in there is going to be larger in that other one. So all things to consider as we do. So there's an example though of where it is really pretty much up on hold line, and you can see it's okay. Port Phillip down South Melbourne area there, and they're okay with that. It's not trying to get vehicles through there or continuing to circulate. That's all okay. Just because Adam said Bendigo, I thought I'd better put a picture of Bendigo in there. So that's this one's in Bendigo down there, Coffee Club. And you can see that nice setback, and it works very well, exactly as Adam said. But one important thing I really want you to remember is that perpendicular, anything raised on the road network, we want to have it perpendicular to traffic as close as we can. We don't want these skewed angles where heavy vehicles are going to be rocking as they go over it, or motorcyclists are on a bit of a lean when they go over it. So we try to make sure it's perpendicular. So think of that on your approach to the roundabout, trying to square everything up. So here's an interesting one, which is actually a signalised one in New Zealand. And they're proposing to put a raise this signalised crossing, which I think is a wonderful idea. And I put some photos up in Prue's session or into the chat of raised signalised intersections. What do we think though? I mean, this is on a curve. It's going to have larger vehicles sort of hitting at slightly off angles. What do you think we do? Is it a position where we say, well, we can't do anything raised because of that? Or does anybody have any ideas? Pop it in the chat. How could we still maintain our ideas there of getting the vehicles to slow down at this conflict point for pedestrians, but accounting for trying to make things a bit better from that design perspective?
Oh, Ken, with this thing, you're gonna get solutions.
That's what we want.
So we've already got 3 solutions. 4. Yep.
Yeah. Okay, I'm seeing them sort of come in there, and they're hitting the nail on the head. So absolutely confident now people are sort of getting these principles in their mind. I like the ones there of flaring it or making it wedge shaped. That's what they ended up going with to try and straighten it up. So you can see that the crossing is still, it's same and straight, but the actual point where the raised has been tried to put more squared up. But I do also like that idea. That's an aerial image of that spot where, you can extend lengths of ramps and these sorts of things. Or you could look at cushions on the approach and slowing on the approach rather than just there. Positioning of crossings and things at roundabouts. Some good documents around Australia again. Vic Roads has got a good document there. The bicycle and pedestrian treatments and roundabouts. PMR sort of splits it across 4, but I think there's a newer one that might consolidate a lot of that. Okay, another one on that setback. I mean, the same principle applies when you do have these paths running parallel to a road that you want to provide that priority for the path. Now, this one's at Bolton Street, I think, and it's an interesting one. It's that same theory of the give way sign here is actually for the shared path. This is, they do put a hold line on these ones because it's not a pedestrian crossing. And don't know why they picked green here. I'm not sure what's going on. That should be yellow because it is a shared path. But anyway, that must have slipped through the cracks somehow. But you can see there's that point where a left turner can pause out of the traffic stream, or even a right turner can pause out of the traffic stream as well. So, you know, you've got that point there that they can sit there. They're not in the direct line of being struck by a through vehicle or holding anything up, and it works really well in those situations. And somebody doesn't like the it's good spotting. Unless I need to answer anything crucial there, Hafez, I might jump in and talk about ramp grades. There, look, there's you and I, Hafez, out there at measuring some ramp grades.
I love that day. So no questions, some observations, and I really like the people interaction in the chat room. So please keep it up. So let's go, Kim.
Right. So first of all, and I'll just reiterate this, I think I said it in the chat or I said it in Prue's one, vehicles slow down on the approach to a raised thing. It is not using the raised thing to slow them down somehow. It's not a speed dampening device as such. They see it, they judge it, and they slow down. It wakes them up, right? Because they physically have to go over this thing, all right? And then they make their judgment on what's appropriate. It's not going to damage their vehicle and not going to, you know, hurt themselves. And then they navigate, they get that speed and they navigate over, okay? And we basically can affect what speed vehicles will get down to before they go over it by how sharp it is. That's partly due to them visualizing it, but it's also partly due to them doing it once and learning. Okay, and because the bulk of drivers use the same area, we can influence them by putting speed advisories, but your speed advisory only works if the ramp grades correspond to it. If you put a speed advisory of 20 on a very, very shallow grade, it'll be driven at 20 the first time, then it'll be driven faster and then faster. So a pretty stock standard Wombat crossing, raised crossing, sits at about 100 mil high, there we go, 3.6 wide, 1.2. So prize for anybody who can tell me that ramp grade. We'll see how many of the actual technical designers we got in there. Ah, Daryl's quick. Daryl's quick, 1 in 12. Yeah, that's right. So that's basically, it goes up 1 and out 12. Okay, so 1 in 12 ramp grade. Cool. Just be aware that your ramp grade's also going to be relative to the longitudinal grade of the road. Right? So if you've got, and on a steep hill, you've got to be thinking about that grade angle that we're talking about there. So just pointing that out as a design consideration. But this is really important, and I like this chart. It's a really good one from Cameron Munro there, and there's a nice table here from the road design note on raised stuff. Raised intersections it is, but the ramp grade stuff applies as well. But what we've got here is vehicle speeds you can expect, and then we've got here no speed response, okay, some reduction in speed, which is green. That's what we're aiming at, because above that you go into vehicle damage, right? So what you can do is you say, okay, what do we say? Oh, it's a 1 in 12. So let's highlight that line. And then we're basically going to get vehicles getting themselves to around that 20, 25-ish to navigate through a 1 in 12. And that's where it'll settle itself very quickly after you build it at a 1 in 12. So then, you know, you can see there the different grades elicit different speed responses. If we go to a 1 in 16, we know we're up a little bit above 30. Now, to save you all the hassle of trying to find out all these different things and local requirements and the different stuff, I've put some information in there from Austroads, so dot pointing those out, the Australian standard, which has a sort of generic wombat crossing, indicative dimensions, platform heights, and the like. So those are in there. TMR's got some specific stuff as well. TMR, like said, desirable 100 to 150. And 150 it's high. That's a really high one. I caution you on that, not because I don't like, you know, really slowing vehicles super down. I'll show you shortly why I caution you on that. And just be very, like, you really want to do some design thinking if you're going to go up to that height. And there's some NZTA stuff in there as well, which I've put in. You can grab out of the notes. So, you know, we can be down as low as 50 mil. We can be up as high as 150. And then, you know, you can start to play around with the end grade you get. So you could elongate it out that way, sticking to 100 mil high and making it longer, which would shallow it down. You could, yeah, you know, you might have high and short, and then we're in really steep territory, or you could steepen it out. You could have lower and flatter. And they're all going to elicit different speed responses and have other benefits. I mean, the higher it is, the easier it is to see, the more clout it's given in terms of not vehicle hitting it, but people are going to notice. They're really going to say, yep, I'm slowing down. So but the reason we can get concerned is we've got to think about all these different vehicles. And yeah, if you have a very high ramp, you're going to have front bumpers hit. It's going to bottom out as it mounts the ramp in there, and you may have your back end depending on the length of the vehicle after its rear axle. And you may scrape it coming down as well. So they're sort of things you want to be considering. I'm just sort of putting cartoony things out to explain the concept, so it's hopefully understood by people. Oh, you might also front out coming down, depending on the grades and those sort of things. So what we need to understand then is a bit about vehicle regulations and what can vehicle, like, what are we expecting vehicles? Are vehicles like, you know, 20 mil off the road surface and big, long, hugely long wheelbases? Well, no, we don't allow those on the network because they will get stuck on everything. And so there are some minimum ground clearance requirements in vehicle regulations, and you can see, you know, 100 mil from different points is really what it is. And so that's becomes important for buses as well, but you're not going to get a lower vehicle lower than 100 off its axis too much. But 150 is starting to get in points where vehicles that are within our acceptable vehicle design criteria will be bottoming out over humps, unless you've provided really long approach ramps and a long sort of central surface. But buses are one of the key ones for us to think about as we create ramp grades, heights of ramps, and lengths of platforms. So when you look at a bus and its general minimums, I mean, the 100 still sits in there as a minimum, but it's not just about the 100. It's about the distance off the axles we need to think about, right? And so they'll always put in vehicle regulations across Australia and New Zealand. There's always that percentage off the axle that you got to think about as well. And that comes into play as we try and go up and down over a ramp, and your overhang and your rear hang. So really, these sort of absolute sort of minimums that you would expect out of a bus, you're not going to find on your passenger buses and the like. They'll sit higher than this, but you might find a coach occasionally, or maybe that, I don't know, the stretch limo or something that's, you know, coming around like that. And the thing is that you do want to cater for that. I mean, this is these are standard commuter buses out of New South Wales, where we're seeing that like 190 clearance there off the 6750 wheelbase, and 260 clearance on a longer wheelbase there. Articulated buses, and you can see 200 clearance off the articulation. But you know, the longer your wheelbase, you're going to have to go up a little bit. But anyway, the point being, again, that like if we have these high ramps, there's the possibility that a coach, like coming into an area, literally can't get their nose over it. They will hit their nose on that raised crossing. Or they might bottom out over the top of it once they're over it, or they'll scrape their back on it there. So National Heavy Vehicle Regulator puts out some specifics around buses and the like to help you in that design choice and thinking. But certainly, I mean, here's an example of a coach going over a 100 mil, 1 in 15 ramp grade. It's fine. The coach goes slow, right? If this was a route that had continuous commuter buses, right, always going through there, that might not quite be the right ramp grade and height. However, for the occasional coach that comes to pick up the girls from school here and take them around, and, you know, a couple of buses a day, maybe, that's fine. Absolutely easy to navigate. Think about your longitudinal grades, okay? It changes. If that's downhill into that, very different. But that's a very fine setup for all road users meeting the Australian design rules for vehicles. If you've got commuter buses and it's a constant bus route, you might want to start adjusting your ramp grade. I think this is a nice balance here down in Sunshine, where we've got 75 high, we've got a 1 in 20 ramp grade, it's good at slowing vehicles down, right? It's a generally slow speed environment anyway, and the buses are really able to navigate that really quite easily. You can extend out so your whole bus gets on top of it with both wheels over it. That's an option as well. I won't go into that in detail. I'll do this one and then I'll take maybe questions if there are any. So down in Warrnambool, 75 high bus route, concerned about buses, designed at 75 high, 1 in 27 ramp grade. That's flat, right? You're going to expect speeds around the 50, 55, 60 kilometers an hour. There is almost no point in having raisedness to this. That's not slowing vehicles down in this area. Okay, so that's gone too far in the other direction in terms of that. So yeah, I'll leave it at that. Questions for me, Hafez?
So we've got a number of comments here, you know, in line with your conversation about emergency vehicles, buses, heavy vehicles. So people agree with you and have shared some comments about that. Also, we've got comments about, you know, how sometimes design actually is used by the police to understand which vehicles are not the standard. So that was a creative police work there.
Yeah.
So we've got the comments from Ian here. We sometimes have steep approach and longer departure ramps allows more comfortable PT, but splitter islands are needed to join the different grades. That's good comment. So we've got a question. How does the design speed vary from operating speed in the design of the race safety platforms?
So the design speed is what we would design speed in general is sort of what speed are we going to design things for. Operating speed is physically, once they're out there, what do we actually see the 85th percentiles of speed operating through an area. So when when I talk about ramp grades and the speeds we're designing for, that's what I talk as design speed in a race crossing, and the operating speed would be it's built and you actually see what people are operating at through the thing.
And Ken, I see sort of potentially confusion here. What is the difference between raised crossings and raised safety platforms?
So a raised crossing will have the pedestrian crossing marks on it. And then a raised safety platform could be deployed at an intersection, for example, that may not have pedestrian crossings at all, and it's just to slow vehicles at these appropriate points. Or you might use a raised platform at other locations on the network just to slow vehicles down, similar to a speed hump, but more with that flat top to it.
Thank you. So Kartigesu, I think, so you mentioned race safety platforms. So this course is about race crossings, but I would put a reference here for race safety platforms as well. Thank you, Ken.
Yeah. And I mean, the principles of the ramp grades and everything, just exactly the same. Like it's all about slowing the vehicles down. But okay, like you're at that point and you're going, oh, well, the bus company's jumping up and down, or for some reason you can't have your ramp and your ramp grade and your full race crossing. Well, you may be looking at speed cushions, and I'm very this to me is fine. Like you get great safety benefit out of it. It's not quite as good as raising the crossing, because if the crossing's raised, well, one, you only need one raised point and it's right at the conflict point. So your vehicles will slow on the approach to it. So you don't need to do both sides. So that's one reason. The second one is that it elevates the user you're trying to protect, and so they're in better eye line. And then, as Bridget talked about, it's easier to navigate if it's that continuous grade for the pedestrians and those in wheelchairs and gophers and the like. But nonetheless, like the cost of this compared to the cost of the full raised crossing is often just like they're leagues apart, and we get a huge safety benefit out of this. Plus, sometimes you just cannot do the drainage. The drainage just won't work with a raised crossing, but you can get it okay with this sort of stuff. Buses obviously can straddle these, so you can get these deployed out cheap in scenarios where people have abandoned the idea of slowing vehicles down, which is not what we want to do at these points where we know people are going to be crossing. So you'll see there, and there's another picture of one up here from Queensland, from Peru. They're done on both sides on the approach and departure. And that is partly to address that comment that was made around people are going to go around. So you're doing both. You don't need it on the exit if everybody you could guarantee would stick to their lane. But no, we're designing for people being people, and they're going to try and drive around it. But you do that second one, so that sets that. Or, as you can see sort of down here, you could do things like a splitter or a lane separator to try to do that. Now, I mean, that one, you'd probably want to extend it a bit more. So they sort of trap them in, and they'd have to make a very, very actual, very forward-thinking acceptance of driving the wrong way down the road before coming back in. So they're pretty good. I mean, all the ones I'm showing there are spike down rubber ones, which you can just buy off the shelf. Plenty of people sell you those, so that's all good. But you could, if you want something to last longer and better on maintenance and the like, you can asphalt them in, and that's a really nice, long-lasting treatment that's going to be there for a long time. Helps out with some drainage challenges, and it's generally pretty good. There's some standard sort of heights and dimensions for speed cushions to ensure that a larger vehicle can straddle, being our buses predominantly, and that smaller vehicles are going to really slow down. It's a bit hard to straddle. So, but you buy them off the shelf, and that's what you're going to get. Or if you're asphalting in your own, you can have a look at that.
Ken, we've got a very specific question here, and I've sort of paraphrased the question in 2 questions for you.
Yeah.
So what is the best design approach for a platform of a raised pedestrian crossing on a road with a steep gradient towards the crown?
Yeah.
Should the platform be kept flat with varying ramp grades, or is it more advisable to design the platform with a longitudinal gradient?
I have one thing coming up that sort of starts to address that. I think if I'm getting the question right, we don't want to make our path for pedestrians or cyclists too steep either way, especially with horizontal grade, because people in wheelchairs will sort of fall out and those sort of things. We've got to be a bit careful with that. I'll come back to it, and if I haven't answered it properly, whoever asked it can shoot me an email, and I'll delve into it. I just wanted to pop this up. This was from like, this would be like 12 years ago in Perth at a road safety conference, and we had a little bus trip out to have a look at this. And I thought, geez, this is great. And I dug it out of my archive after last session. We were talking about raised signalized crossings, but isn't it good? Like, okay, we've got a pedestrian crossing there. It's in an area where it gets lots of crossing points, people crossing and the like, and we've got to slow vehicles down because we know occasionally some, if we don't, they're going to run the red light. But this really stops them running the red light because they've got to navigate over this. They're slowing down, the foot's on the brake, and something happened, it's going to be at low speed. And this, cost-wise, is very, very low. And like if you've got your existing signals, that is, and you're just trying to make everything safe. Somebody mentioned also, like, you don't need to have ramp grades the same going in and going out, do you? Like, you can, the reason you do have ramp grades the same going in and going out most of the time is because it's an undivided road. There is no splitter island down the middle. And then if you alter it, you've got these 2 different grades. You can see that this one has the island in the middle there. It means a vehicle coming in here isn't going to drift it off and have one wheel on this shallow ramp grade and one on the other. So that's what you're trying to, that's the reason why most of them are the same. But you can see that there's 2 different ramp grades, which is okay. And that can help with the exiting of vehicles. How am I going on time here? Okay, no, we're doing all right. So here's one, and the example is it's quite a downhill to this shared path crossing, and that then presents a lot of really interesting challenges associated with and kind of addressing the question I think that was being asked, because you've got downhill and 8% grades down, and you're trying to provide this crossing, and what sort of angle are we accepting on the crossing itself through there that the road users aren't sort of sliding off. So you get this in this awkward adjustment. There's some stuff in the Australian standard on particular grades you can be acceptable. But and again, the theory of it is that if we make in these situations a fairly standard cross section there of a platform, you can see that the bus is going to like just bottom out straight away or nose out. You've kept your crossing flat, but that's not going to be able to get vehicles through there, and it'll just get stuck on the top as well. It'll just perch up there because you've got to. So I've exaggerated everything hugely here, but just to give you the concept. But you can flatten things out to a degree, and then elongate out, and you can get a better treatment. You start to really elongate out sometimes to get your ability for vehicles to navigate it over it. But you can see yourself getting some slowed down features that are traversable back and forth for your larger vehicles, and just within acceptable ranges for the angle of the crossing. So, you know, in that one, for example, you'd be really extending things out significantly in the way you shape it down coming out of that crossing. Okay, so I've talked through sight lines and I've talked through ramp grades, and they, to me, are really, you know, important things for us to be thinking about for raised crossings. They're major impacts on the safety outcomes we're going to get. And I go into some other sort of civil features here, which I'm not going to go into a lot of detail on just due to the time we've got. And I can point you at different documents, which I'll do it, but I'll give you again the high level principles of lighting, for example, and drainage and the like. So 1158 is our Australian New Zealand standard for lighting for roads and public spaces, and part 4 of that is lighting pedestrian crossings. This doesn't differentiate between a raised crossing and a zebra crossing or a pedestrian crossing, and I sort of feel that there's some work to be done on this, because over excessive lighting requirements, again, can stop us getting crossings in where they can be pretty safe. Now, there might be an argument on these at-grade crossings that, you know, the lighting is particularly important. Vehicle speeds aren't going to be slowed down, and they're really reliant on having very clear vision of these road users approaching, the pedestrians approaching and crossing. But if you raise it, you're lowering the whole risk there. But you're thinking about lighting the pedestrian, okay, in 2 planes, but there's also the requirement to light the pedestrian. How do I explain this? Pedestrians need to see each other when they're crossing at these. So, yeah, I suppose it's for maybe a personal safety sort of thing, but you should be able to be identifying the other pedestrians crossing. So the theory on it is a vertical plane and a horizontal plane where you're checking light. So you want to be checking light at each of the points throughout here, okay? So that's that one sort of 1.5 meter up. There is the light getting there, and then down at the ground level as well. So you've got to be really sort of careful with your lighting, because we do need to ensure that the priority road user is lit crossing the road. Light spillover becomes a challenge, and just getting lighting in, and you know, the cost of it and those sort of things is a real challenge. There's been some really wonderful advancements in solar powered lighting, and anybody who's struggling to get lighting in with costs and with time delays and all sorts of things, talk to the City of Greater Geelong about the solar lighting that they're using. And I can email people some information on it, but they're deploying them out quick, and they're cheap, and they're very effective, and they have plenty of backup. So the City of Greater Geelong's really leading the way there, and some other municipalities I think have followed suit. I just know that City of Greater Geelong's done a heap of work on that. So that's some really good stuff. In terms of those other crossings, we've got to think about lighting. You can see here TMR's guidance. They talk about lighting 10 meters back. I would prefer you to do that calculation on A and make sure that that lighting is all the way through and through the crossing as well, so that an approaching cyclist is lit at a point that a vehicle can see it. I'm not so fussed at lighting back here. I'm not so fussed because I got headlights, and the rider will see the vehicle approaching. All right. So lighting is a huge challenge often to people with these. As I said, I'm happy to share some of that information. I could probably drop it into the learning management system so everybody can access it. but drainage is often one that really inhibits the installation of raised platforms. And it's really important for us to consider this and think of all the ways that we can still get the principles and the outcomes we're looking for, but account for all of the water, the deluge that we may be dealing with. Okay, so let's just summarize at this high level what could be done. I did see this first one, keep the curb and channel, when I was out and about, and I thought that's definitely not going to cut it. Maybe the water's okay, but the pedestrians will not be doing too well climbing down the curb and then on and up there. Okay, but the options we've got are sort of low ramp height, so the water will flow over essentially. Positioning, and if you can position a raised crossing at that high point, your water's going to flow either side, right? Now, don't position there if that's not pedestrian desirable. Like, don't let your drainage dictate that and expect pedestrians to walk 20 meters up the road. They're just not going to do that, okay? So, but that is an option if things can align well. I'd love to see some of that thinking early on in subdivision design and things like that, all connecting together, but that might be a little bit too much to ask. Okay, but then you've got the ability to ramp down and up within a distance, so your grades aren't too bad. And I'll show you some bigger pictures of that later. Then you've also got the idea of a box drain or some sort of plate over, so you've got a drainage channel through. And then you've got your usual pit and pipe arrangements and expanding the capacity of that if you need. So, pit and pipe, you may need to add more to that. This is going to be an expensive way to do things, but it's very good. It's very effective, and we can certainly do that. This one I like a lot, and we're seeing more and more of it. It's where that sort of plate of some description is laid over the channel there, and we keep that straight access and water flows under. And you can see it there. The challenges, and I'm sure some of you have faced this many times before, is actually I got some good pictures before I get to a bit of a challenge. Nice setup there. The challenge is like you see here, and they need sort of constant maintenance and clearing or ensuring that that's the case. So here I am with my colleague Chris Hall, who some of you know, out there doing the post-opening audit of that, and that was only sort of 2 weeks after opening, and it already clogged up. So it needs attention, and it's just something to be aware of as one of the potential challenges to face there. Within that side is another interesting one, actually, that the idea of utilizing the curb outstand area vegetation to have some openings there, so your water can come in, drop down, but it also acts as a bit of a retarding basin or an area where you can even have a bit of water sensitive urban design and things going on. Again, you've got a bit of sort of, even when you have these sorts of features, some leaf challenges. There's that other one where you've got water that can kind of sort of come in, go down, a bit of an area where it can take a small bit of time where there's extra water that comes in. So often a big concern around these, and it's something that everybody does need to think about, is how steep can you have this? And this one works really well on a fairly flat roadside to crown of road area, and you can transition down and up, and they work out in a reasonable way. So I think that's a decent example there. You can see these ones where you've got that ramp grade, which comes in fairly almost flat. It can ramp up and ramp down. That's actually it's a cheaper way to do these. It's very effective. I'm generally happy with it in a lot of locations where you've got a bit of space to work with. But as you get more constrained and steeper, it doesn't tend to work so well for a number of road users, being wheelchairs or people on those Gophers, mobility scooters, and And even older people start to have that challenge of going down and going back up. So this one's starting to get into the too steep range. This one, I scratch my head at a lot because, okay, it's not too bad. We've got this little curved lip and things like that. And I say, well, the amount of money that's saved by doing this rather than subsurface drainage and everything like that is big, and we can get more of these out there, and that's a wonderful thing. The challenge you've got, though, as I said, of then so watching this lady sort of slowly navigating down, very slowly, step by step, trying to navigate up and get up back on. So that change has been a problem for it. But then I go again, but we've got slow vehicle speeds. We've got people with a clear priority. They're going to stop. It's a safer environment. Don't get me wrong. The ideal would have been to have this all nicely flushed through, step-free and the like. But I think, again, if the choice here is between this and no raised crossing or a at-grade pedestrian crossing, I'll choose this every time. Signs and lines. Whoa, sorry, somebody's calling. Okay.
Ken, do we have a minute for a few questions here?
Yeah, I'm just gonna sort of mute.
Sorry.
Okay, sorry, my bad. I don't know what happened there. Something started. Okay, yeah, what are the questions?
Sure. So there's a question about construction, and are we going to cover any comments about construction, the type of different material, or do you have any reference for them?
I just have one slide on it very briefly. I'm not going to, and it's not, to be honest, that's not my area of expertise, but I can definitely point people to some wonderful people in that if they've got particular construction challenges.
That would be fantastic. People also talked about accessibility and wheelchair, and I think you covered that question, so that's just all good. Jason talks about that 1.6 meter setback, especially when you showed the photo of that elderly woman with the walker.
Yeah.
So where is it calculated from? And the last question for you is, in one of the photos you showed a curb out stand with a grill sort of in a drainage. Where is it?
Yeah. That's in Richmond, on the boulevard in Richmond, just outside Melbourne Girls Grammar.
I love your memory.
That one.
That's it. Yep.
Yep. Okay. Signs and lines. So this one's kind of easy because 1742.10 just has a beautiful diagram that says it all. And it's nicely in there. The idea is advanced warning if you believe it's needed of the pedestrian crossing and the raised feature, and the legs on the approach side and the other side of that sign face, no stopping signs. So that setup's in there. 1742 clause 6. It's nicely laid out. Is it too many signs? Yeah, probably. You can do some different, setups there. Think about your height of those signs as well to make sure they're within those clearances. And if crossings are, a bit harder to see, make sure you've got warnings of them coming up. This isn't a done thing usually. 2 regulatory signs on one sign. Some people get very angry about it. I don't particularly care. It's a low speed environment, and it's okay. But yeah, in theory, that should be separated, 2 regulatory signs. So that's the sort of standard setups we've got from Road Design 0307, this one. It's pretty good. We're using that sort of, well, it's a very green one in that picture, but it's that fluorescent color. And I'm still promoting our concept of a regulatory legs and raised crossing sign of some description, which would help alleviate some of the sign clutter we have to put out on these when you're following that particular set of guidance. New Zealand has a different setup altogether. You can see there that's the Australian piano key marking. New Zealand has that hold line, has the optional diamond on the approach, has the little triangles to delineate, and that's all there in the different Wakahi guideline documents. So you can just simply follow that, and then there's the little orange stick things that they use, and a slightly different warning sign. The New Zealand also uses that give way to pedestrian cyclists for that shared path crossing as well, though. So just be aware that's another option available. And then when Australia does the shared path crossing, I think you've seen enough of it now, but you're creating essentially that road intersection style signage where you're giving a give way sign facing the traffic so that the vehicles can go through. And there's some of those specifics of it with the two pedestrians and cyclists to give way, advanced give way sign if you want to use it. Just a couple of things to point you at, which I'm not going to go through. Flashing lights, there's some information in there when you'd use that. Tactile ground surface indicators, 1742.4, RRPM 1742.2. Look at those yourself. And I think I've covered off enough of the shared path crossing signage and line marking, but Roger Zarnato 307's got good information if you're interested in that. Just on that, one of the things generally being discouraged is red, and the reason for it is the information collected on contrast for some people with specific vision. So trying to stick to that black pavement as much as you can with the white markings. I'm going to jump through that. I'm going to jump through that. But you can see quite a few signs put up there. The last one before I jump you into learning management system was to talk a little bit about pavement, but really not much. I mean, the only bit that I really wanted to point out, and I am not an expert in pavement and pavement construction and these sorts of things, so I can't really talk too much more. But it is just ensuring that you box out there, because you can't just put the, if you've got that nose angle and it's too thin, it'll just be breaking away. So you really box out there, fill that, and then you get to your ramp grade from that. Concrete's easier. Concrete is easier to get that ramp grade, although it's harder to construct and takes longer and is more expensive, but it's a really nice one. The other sometimes challenge there is also continuing to maintain contrast between the color of the concrete and the white line of the marking. So it's another sort of factor and consideration you can put in there. Okay, I think I better show the learning management system.
One last question, Ken, from Grace here. Do we have a specific signage for raised intersections with pedestrian crossings?
Well, you'd put your raised crossing, you'd put your usual leg markings if it's a wombat crossing, like on a slip lane or something like that. If it's a signalized crossing and it's got a pedestrian crossing, you just use the raised because the signals do the usual stuff themselves.
And asphalt versus concrete?
Well, yeah. I'll let others decide theirs, but I mean, concrete is going to be, as I say, easier to get your ramp grades and things like that, but I think it's more expensive and has that contrast challenge.
Awesome. So thank you, people. And if you have any more questions for Ken, please put it here. I'm going to pass on to Ken, and Ken will come back to you. Now we go to LMS. Thank you, Ken.
Yeah, so you're at the end of the course, and you're probably, yeah, like there's a lot I just covered there. So you have no doubt been in here. Hopefully, as you're seeing this, and you've got resources here, and within these resources, you can see here. Well, there's lots of cool stuff, but here's a whole folder: design and engineering resources, and that's where I've put in a lot of that stuff that I talked about. So you'll be able to find those. And I might chuck another couple of things in there based on some of the questions that came up. You've got everybody's slides and some different cool studies and things that they pointed out. You've got the recording of each of their webinars there. And in my one, you've actually also got a quiz. And this is a quiz about the whole course. And it's just 10 quick questions for you. And we want you to complete that, you know, you won't find any issues, I don't think. But once you completed that quiz, you go here and you complete the course feedback, and then hey presto, your certificate will appear. So you're going to have to just complete a short quiz, and then feedback. And then certificate appears and you can download it.
That's delightful. And Ken, thank you very much for putting so much energy to your material and presenting them and addressing questions. It's 2 hours, like the tour de force of design. I'm very thankful to you, and I know people here really enjoyed it. I hope so many questions, interactions. Thank you, Mr. Bia.
Great group. So if you have any questions about accessing any of that sort of stuff or the like, just email back to training@safesystemsolutions.com.au, the one that sent you the email. However you've got to this stage, you have an email somewhere, just reply to it. They will provide you with the link and logins and anything like that. Awesome. Hey, thanks everybody. Love this group. Thank you, Hafez. It's always fun doing this with you.
Absolutely. And look, we had some fantastic people in this course. I really cannot mention it enough. Well done, people. We really loved and enjoyed having this course. And on the point, 1.59, 2 hours. Ken, you did a fantastic time management too.
Yep. And
Excellent.
More raised crossings, people. Let's get them in. Let's get them in.
Yeah.
Thanks, everybody.
Thank you, everyone.
Have a good weekend.
Have a good weekend.